Okay, so I think we're going to try to work this problem with both a portal and cantilever method. So let's begin by the portal method, okay? So I think predominantly I'm going to use the good note because it's a lot easier to write, but let me begin here with the PDF so that I can show you the basic. Now what? What's going on here? Okay. Can I? Now I lost my pen. Huh. Funny how, you know. So let's see if I could go back to that, but let me. Huh. I can connect my. See, I think I just recharged it yesterday. So now it's gone. What do I do? One moment, please. Better stop this record. Okay. Now this is the frame that we're going to work on, and we're going to try the portal method first. Okay. All right. The portal method. But I should like my pen to be thicker than this. Okay. In portal method, you can see that you can count that you now have like 1 portal, 2 portal, and then 3 portal. Okay. And you can add your, does it again. Okay. You can add the hinges in the middle like this. 1, 2, 3, 4, 5, 6, 7, and then of course more. 8, 9, 10, 11, 12, 13, and 14. Now you see you have 3 portals up top, and you also have another 3 portals, the total 1 at the bottom. Okay, so based on this, we can cut the free body diagram here. Black would not be a good idea because it's just too similar to the frame. So let's just use green. And now because like I demonstrated before the break, you now have 2 exterior columns and 2 interior columns. So that means you have 1 shear here, and then 2V here, 2V here, and then V here. So based on the first free body diagram, you have V, 2V, 2V, and then V. You can say 6V is going to be equal to 20. Okay? And now, so let me try to write down the first free body diagram for you here. Oh, again. That's why this is really this, you know, not very convenient at all. Right here, okay? So your first free body diagram is this one. It's a little bit short. So cut through this line, through the first line of your hinges. So you have 20 here, and that's a V. So you now, because right here is 6V is equal to 20, so V is 20 over 6 or 10 over 3. All right. So that means now we already solved the shear. That's 20 over 6. That's 2V. So it becomes 20 over 3. That's 20 over 3, and that is 20 over 6. Notice that your sigma fx should be okay. Okay, and then the second free body diagram, I'm just gonna cut through here. Maybe I change the color to be a better idea. Okay, the second free body diagram, we cut through the hinge on this level. Okay, and now from this, again, you will have V, 2V, 2V, look like a V, that's V, and then another V. But this time, your free body diagram is this one, you know. Let's see, let's try to move that a little bit, okay. This time, your free body diagram is going to be this one. Let's make it longer. Because we cut through the hinges on the first floor, so to speak. So this is going to be your free body diagram. So that means your external force is 20 plus 40. And this time you have 6V equal to 60. So 1V is 10. So that means this is 10. This is 20. This is 20. And then this is 10. See how easy that is? So by using the Porter method, we assume that each column will take the equal shear, and the internal column can be broken into the two exterior columns, you know, the equivalent of two exterior columns. So we can use that to easily solve the shear. And now we can go about step by step and start making our analysis on each member once we know the shear. So I'm gonna swap to my good note, okay? But before that, let's say, hang on a minute. Okay, I'm gonna tell you that I will, which color should I use? Yellow? I will do the columns first. Okay, and then from the columns, you can move on to the beams. And then you probably need to be pretty good at free body diagram, which you all should be, right? And you need to be good at concentration as well, because from now on, it's what we call the bookkeeping job. The calculation is not difficult. You just need to be concentrating on your job, okay? So from that, remember now for the first one, if I'm, you know, let's go back to this a little bit, and I think it would be better to name the, let's try this because I have never done this before, but if I am going to do something different, oh, shoot me, that's a lot, right? Let's call this column, how many, we have like 8 columns, 6 beams. So let's call this column number 1. This is column number 2, column number 3, and then column number 4. And then this becomes column number 5, 6, 7, and 8. Okay. And let's try to call our beams by letters. Will that work? So that would be, ooh, here we go again. This would be beam A, or let's be more professional. Let's call this what do you prefer, A, B, C, or B1, B2, B3? No feedback as usual. So, okay, this is structure analysis. So let's say this is A, B, C, D, E, F. That's the names for the beams, okay? So we have column number 1, 2, 3, 4 on this floor. 1, 2, 3, and 4, and then 5, 6, 7, 8, and then beam A, B, C, D, E, F, okay? So I'm gonna work with column 1, 2, 3, 4 first. Remember that we already know the shear, okay? So let's come here and start working with our free body diagram, okay? So let's say we are looking at column A, okay? So the free body diagram that I have now would look like this. Okay, I have the shear going on here equal to 20/6 or 10/3, right? And therefore, to balance my sigma fx, let's say the black one is something that I already know. So this, to maintain the sigma fx equal to 0, I have to have this equal to 10/3. You guys follow? And now because we assume that our hinge is here in the middle, I can take moment at the internal hinge, and I can obtain my moment now. Okay, so my moment is going, you know what? I'm gonna use the color red. My moment is going to be equal to 10/3 multiplied by half the length of the column. Okay, and because our column, I believe it's 4 meters long, so this half length is 2 meters. Okay, so I can say that my moment is equal to 20/3 ton meter, and you know this blue shear is going to the right, so my moment here should go counterclockwise, and the black shear underneath here goes to the left, so I should have another counterclockwise moment here, and that is 20/3, and that is also 20/3. Okay, so we now have a rudder column under equilibrium, but this is not finished yet because you don't have the axial force. Okay, you can repeat this with column B, okay. Column B is going to be the same. You have a hinge in the middle. Now you know that shear here is 20/3. Okay, so you know again that this is going to be 20/3, and let me try to make it look like more like a 3. 20/3. So likewise, I can calculate the moment here. Now it's going to be 20/3 multiplied by 2, which is half the distance again. Okay. So here is 20. That's going to be equal to 40 over 3. 40 over 3. And this is another 40 over 3. Okay, so that's column B to you. If you fail to follow me, please do let me know, okay? And you can guess now that column C it's going to be similar to column B. That is because it has the same shear. So in response to that shear, we have the same shear up top. And as a result, we have the moment of 40 over 3 and 40 over 3 here. Don't forget the unit, meter. And last one is column D. That is similar, okay? Column D, which begins with 10 over 3. And so in response to that, you have 10 over 3 here and the moment of 20 over 3 and 20 over 3. Okay, so is there any question?
Teacher,
yeah,
sorry. So moment we consider with 10 over 3 blue color or red color or black color.
Well, both.
Oh yeah. Okay.
I use the black color to indicate that you got this shear value from this. Okay. All right. So you got this shear value from here. Okay, from using the portal concept to sort of average the shear value out on every column. So that's how you got the a rather average value. And then you put the shear 10 over 3 here. So as a result, you need to have the blue shear on top so that your sigma fx is equal to 0, right?
Yes.
So then you use the both shear and take the, you cut the free body diagram at the hinge here. So basically, if I am going to draw the free body diagram, I can draw the free body diagram of this piece, right? So then that becomes this, and then the hinge, and then you have 10 over 3. So you can calculate the moment by taking the moment here, right? By doing that, you get this moment, which is equal to 10 over 3 multiplied by the moment arm. That is 2 meters, right? But keep in mind that you still don't know the axial force. You don't know this yet. So it's not complete. Now you just complete the job on the moment on the column. You just got the moment on the columns, okay? By simply using the shear that you got from the portal concept. Right? You got the shear first, the shear here. You got the shear here, then you got the shear there because it has to be equal and opposite. So now you got the values of the shear on both ends of the columns. You can then use this free body diagram to calculate the moment. I can write down, use this free body diagram to obtain moment. Okay, pretty straightforward, you know.
โอเคค่ะ thank you ค่ะ teacher
Okay, sure.
เคลียร์ค่ะ
Okay, good. In fact, you can do the same with the columns on the second floor right away as well. The results are going to be the same, right? So let's try to repeat that and see where that leads us. Okay. So we can do the same with column E. Okay. Column E, now that is, I believe, 10. Okay. And therefore, that's 10. That better be 10. And if that's the case, again, we can calculate the moment. This moment is, of course, let me write down for you. And you should know that this distance is now 3 meters. Half of it, we take the advantage of the fact that we assume the locations to Hinge. It may not be there, but it should be close enough. So you can calculate this moment, and it's going to be equal to 10, which is the load, multiplied by 3, that's 30. Okay. So 30, okay. And this is going that way, so that is also 30. Okay, and let's say here, that's column F. Now you have the shear 20. Okay, so that shear better be 20 equal and opposite. And now you can guess that moment here is 60, right? And that is 60. Okay, and you can do the same with G. That's G 20. Oops. Yeah, you know what? This direction of this one is wrong, right? It's 10. Looks like it's a bit of a mess, man. No, that one is correct. The rest is wrong. Sorry. It's just when you have a lot of this, it becomes quite confusing. Okay. All right. So 10 is going to the right. This one is going to the right. That one is going to the right. Okay. And because it's going like this way, so this is your moment 60. That's 60. And same here for EFG, so that's column H, but H comes back to 10 because it's the external column. So that is 10, and again, this is 30, and then that is 30. So, okay, at least everybody should be able to do this. Okay? Now we move on to the beats. Okay? So now let's remember this. If you look at the column A now, you know that you have this moment 20/3 here. Do you see that? 20/3, this one. This one will have to go on to the beam that is connected to the column, right? Please notice that you now have 20/3 counterclockwise. So that one must go to the beam with the clockwise fashion. Correct? Now, again, it can get confusing. So if you are confused, the best way is just to try to draw the free body diagram of the joint. Okay. Now the problem by trying to call the members with the names like column A, B, C, D and beam 1, 2, 3, we don't have the name for the joint. Okay. So let's call, you know, this joint, joint A as well. So please notice that you have 20/3 here. Can you see my orange color? We have 20/3 and we also have the shear. So from that, let's try to stay in this same page. I don't know if you can see this. Okay, let's try to put the size down a little bit. And now I'm going to draw the free body diagram of this joint, okay, coming in from column A at the top. So now you can see that you have the counterclockwise moment. So from that, you have this clockwise moment, right? It has to be equal and opposite to that. Now again, I use the black color because it comes from column A. And now you see the blue shear is going to the right, 10/3. So that means when it comes to this joint, this shear is going to the left. And the value is 10/3. Okay. So these two we got from the column A, but remember that we still have the external load at the joint, 10/3 from column A. So I'm going to use the totally different color so that you realize that this is the not that green. Let's we can use pink. Okay, you have this external load at the joint, which is 20, right? So that means by using sigma Fx, you will get the axial force. All right. Let's try to get the value. I don't know where it is. So to show you that this color, this shear is from calculation, again back to blue. So that is basically, if you multiply that, it's 120 over, no, it's 60/3 minus 10/3, right? That's right. Right? Yeah, so it's 50/3. So now our sigma Fx of the joint is satisfied. All right, and again, the moment here to close it down for the joint, this has to be 20/3, correct? So by doing that, you don't have to do this, the free body diagram of the joint, but if you are confused, you should do it. And if you are confused and you don't do it, it means you can't do it. It means you don't, understand the laws of the free body diagram. Okay, so once we have that, we can start working on our beams now. Oops. Okay, so let me try to get that. Okay, so maybe it is a better idea to start working on the beams without the axial force. We can do the axial force later, but keep in mind that from this, you now have 20/3 rate moment going counterclockwise, right? So that means the moment on the beam should be clockwise. 20/3, right? Okay, and now remember we have this. So you can use this free body diagram. Okay. Now I can say sigma moment is equal to 0 again, but this time you have the moment 20/3. This better be equal to the shear multiplied by half the length, correct? Let me try to do it better. Okay. And half the length is how much? 4 meters. This distance is 4 meters. Okay, so that means your shear is now 20/12, right? Or 5/3, or 10/6, or 5/3. I'm trying to be consistent with what I've done before so that you don't get confused in the end. I don't know why I wrote down 10/6, but anyway, that's 10/6 or 5/3. Okay, so that is going up, so this is coming down. Five over 3. Okay, so now because of the hinge and because we make the assumption of the shear so that everything is actually determinate. So once you get the shear on the columns, so you get the moment on the column, so you transfer the moment on the column to the moment on the beam, and now you can calculate the shear on the beam. Okay, and now you can see because we put the hinge in the middle, if this shear is going down 5/3, should I do? I'm trying to be consistent with the colors a little bit. Not easy. Okay, so I'm going to use the red, which is not the same as before, but the red here shows that I got it after this. Okay, so if I know that this shear is 5/3 coming down, I will know that this has to be 5/3 going up, correct? I got this value from sigma Fy equal to 0. So I calculate the blue one. And the red one, I can just use, actually it's calculation, but it's using of a sigma Fy equal to 0. So it's more straightforward. And now you know, you can see that the shear is equal. So the moment better be the same number as well. All right. And if you want to do the axial force right away, you are welcome to do so. You can take the 50/3 here and put it right there. And right here is going to be 50/3 as well. Are you with me so far?
Yes.
Okay, you see, it's not difficult. It's not difficult at all. You just need to have a, you know, good concentration. All right. So now we move on to the next beam. But this, you shall need a little help from the free body diagram of a joint, because next beam, if I go back here, it's beam B, okay? You know beam B, it connects with this joint where there will be beam A on the left, column number 2 underneath, and then beam B itself. So before you know how much moment is on beam B, you need to take the moment from beam A, which is this one. You need to take moment from beam A. I forgot to down somewhere, so let's say beam A. It's beam A or beam 1? Don't remember. Oh, it's beam 1, right? Beam 1. And then you have this column B. So you have the moment there, okay? So let's to get that. So let's say I'm going to draw the joint here. So you have the moment of 20/3 that's going clockwise. So this better be 20/3 counterclockwise from beam B1. Okay, now we go back and look at that. We have counterclockwise 4/3 from beam column B. Okay, so we should have clockwise moment of 40/3. This is from column B. Okay, so ladies and gentlemen, that means we now can calculate that you need 20/3 to balance the sigma moment of the joint. Right? And if you want to complete this free body diagram right away, do I have it? Oh, one moment, please. This is a lot of information. Okay, you guys have. Let me try to change the color and see if it helps. Okay. You have the axial force coming in from here. See? So that's 50/3. But this one is not going to be 50/3 right away, because you need to go back and look at this. So you have 20/3 going to the right. So you have 20 over 3 here going to the left. Correct? So that means you have to have the calculated one is the blue one. That's 23, that's 50. So you need 30 over 3, or should I say 10? Okay? And then you have this shear going up 5 over 3. So that one is 5 over 3 down, but that's not it. You cannot do anything else. You need to have another shear from beam number 2. And now you know the axial force on column B. Okay? So this is the information that we need to continue our calculation on beam number 2. So for beam number 2, hinge in the middle. So now you can take this moment, the blue one here is counterclockwise. So it better be clockwise on beam number 2. That's 20 over 3. Okay. And you see, you should notice that actually the moment is the same, but the problem is the length of the beam is not. So beam number 2 is 6. So that means this length is 3. So you can easily calculate the shear now again, that 20 would I have enough space to complete this? Okay, so sure. 20 over 3 now is equal to this V multiplied by 3. So your V is 20 over 6 or 10 over 3, right? That is 10 over 3. And likewise, you know, once you got this, you got that. 10 over 3 going up. So this moment is 20 over 3 coming down. And so once you got this calculation, now you would know the axial force on the column, okay? Because this is that.
Excuse me, it's
sure.
20 over 9, isn't it?
Yeah, 20 over 9, you're right. Sorry, yeah, right. Yeah, right. Thank you, thank you. I thought it didn't look right. So I say you do this a lot on the exam, right? But I'm doing it as well. 20 over 9, so that's scrap that. Okay, thanks. 20 over 9. So you can bring that back to that, and now you have 5 over 3 and 20 over 9. You now can calculate the axial force on the column. Okay, so let us try to finish the beam. So we have another beam left, and yes, I think we are going to have to do another joint. But this is going to be quite pretty similar, okay? Right. The black one, this is 20/3 clockwise, so it better be counterclockwise here. 20/3, and the column is pretty much the same, so that will be another, oops, what's this? That will be another, sorry. That will be another 40/3. But this guy is from B2. This guy is from column C, right? So likewise, it's another 20/3 for your beam, and you can guess that in terms of the moment in shear, your beam number 3 is going to be similar to beam number 1 up there. Okay, but let's finish that. Oops. Beam number 3. Okay, we have, oops, geez. We have 20/3. So this shear is again this downward shear from the length of 4 meters. So it's basically 20/3 is equal to V multiplied by 4. So it's, again, V is equal to 20/12 or 10/6 or 5/3, just like the first beam. Okay, and this becomes 5/3. So when you know that it's 5/3, this is 5/3, and this is going up. So the moment is another 20/3. Okay. So we are left with the beam on the second floor and a little bit here and there for the columns. Okay. So let's say we, because this has been quite a long time, it's not difficult, but it's tiring. So you guys, one other break. I'm trying to go very, very slowly today. To try not to miss anything. Okay. Hello. Actually, you can finish the axial force on the beams as well if you want, by taking the force from the columns. So this is 10, right? And then this is another 20/3, correct? From column C, C, yeah. Okay, so that means this is going to be this axial force is 10/3, and voila, like a magic, right? Because that means the this axial is 10/3. You can calculate that this is 10/3, and if you go back to your column D, it's 10/3, isn't it? You see, but axial force is not difficult. You can do it later. The key is that you know what to start. You start off on the columns, knowing the shear, calculate the moment, then transfer the moment from the columns to the beams, then calculate the shear on the beams. And then eventually the shear that you have on the beam will become the forces on the column as well. Okay, so why don't we take a break now, and we'll come back and try to finish this problem. And remember that there will be the portal method to contain with as well, so we may not finish the portal method today, but that should be okay. All right, so let's stop the record.